I'm going to tell you a bit today about what I do, why I do it, and what the future might hold for us. And you probably want to know why you'd want to know this. And essentially, I'm a meat maker, although possibly not in the conventional sense that you would think of, because I grow meat in the lab. And you might think that that's quite an absurd kind of sci-fi sort of notion, but actually if we look back to, say, 1931, Winston Churchill said this. And in the day that seemed quite absurd, but I'm telling you now that I'm part of an international team looking to make meat in the lab. And I want to ask you a question. Have you ever really looked at meat? I mean, taken raw meat and run your hands across the fibres and given it a pull and felt that connective tissue that really gives it that bite? Because I've looked at this a lot and I've thought about it a lot. I think they say that guys think about sex every 7 seconds. Well, if you replace that with meat, and that pretty much sums up my life. And I think this whole obsession with meat and animals and agriculture actually began with my childhood. Because I actually grew up in rural Cornwall. And I had a really, really lovely childhood, frolicking around in the countryside sort of thing. And now I live and I work in London, here in London, where I work as a cellular agriculturalist. And so cellular agriculturists create animal products from cell cultures rather than directly from animals. And you might think, how is someone that's grown up so close to nature ended up doing something that's seemingly so unnatural? And for that, I have to take you back to my childhood, to how we sourced food when I was a kid. And I, like a lot of people, thought the food that was on my plate and the animal products came from animals that lived outdoors and animals that basked in the sunshine. And I never knew anything different, so I never questioned it really. I just thought when I went to the shops, I bought products that came from here. And then I moved to Bath University when I was 18 to study chemical engineering. And I learnt some really, really hard truths. That for the majority of the animals that we farm, life isn't like this at all. It's like this. And I think we all know it exists. We kind of choose not to see it, although we know it's there. But the thing that really got me was it's actually hidden from us too. It's hidden in the eggs in our cake and the milk in our tea. We all hold this romanticized view of farming, and actually the reality can be really, really different. And then also I learnt that it's not just the animal ethics that we've lost our respect for, it's the environment and our health too. Did you know that 1/3 of all ice-free land is used for animal agriculture? And then in turn, directly or indirectly, animal agriculture accounts for 80% of all Amazon deforestation. So we're taking it from the planet, and they're also polluting it. Depending on where you look, between 14 and 18% of all greenhouse gases are accounted for by animal agriculture. And to put it in perspective, that's more than the whole of the transportation sector put together. Plus, if we take examples like this, sorry, I can't see it very well. This is a feedlot in Texas, and all these little dots here are cows. And all their waste, which was once used to fertilise the land, actually goes into these massive cesspools. And this is algae, this green, and this is feeds off the micronutrients within the waste and creates really hypoxic, so really low oxygen concentrations. So nothing can really live and nothing can really grow. And this is landlocked in Texas, but these are leaking into our water systems. And actually, off the Gulf of Mexico, there's one of these dead zones that sometimes reaches the size of New Jersey in the US. And so this is obviously going to affect our health too. 3/4 of all infectious diseases originate in animals. And because of the way we keep a lot of them, in kind of cramped and confined conditions, we often feed low-dose antibiotics regardless of health. The microbiologist Lance Price once said, even the most diabolical villain couldn't have created a better system than we have for producing superbugs. This is a real threat, and it's happening now. And, sorry. And if the way we consume food continues in the way that it is now, and Western society sets precedent for developing countries, this is only going to get worse. It's projected by 2050 that we're going to need 100 billion animals to suppress our appetite for animal products. I thought, there must be something that we can do. There must be something that I can do about this. And so this is where being a chemical engineer came in rather handy. Because, I'm not going to lie, at university, I wasn't really the model student. I would much rather be off adventuring. I wanted to be a journalist, and then I wanted to be in advertising, and then we kind of came on the fact that I'd probably just be a full-time hippie. And so you can imagine my delight when I got to the end of my university course and had to do a final year design project and had to design a chemical engineering system. And so I actually chose one on milk products, because my best friend back home is a dairy farmer. So she's got a farm, they've got a product, they even have a combined heat and power system. Chemical engineers love stuff like that. And of course I didn't get the project that I wanted. I got given one on meat. But this wasn't any sort of meat. This was cultured meat. This was kind of meat that could possibly change the face of agriculture. And all of a sudden, my whole world changed. I worked under the amazing bioreactor engineer, Dr. Ness, and she introduced me to New Harvest. So New Harvest, sorry, I had to change aspect ratios to this. New Harvest supports cellular agriculture projects all over the world. From Mark Posberger in 2013, funded by Google as well, to Move Freeze milk made from yeast. There's Cara Foods egg white made from yeast too. And this is Modern Meadows leather. So this piece of leather is 6 cell layers thick. So if you hold it up to the light, you can almost see through it. So not only are we creating animal products not directly from animals, but we're also creating them with these kind of crazy characteristics that we could never before have dreamed of. And this way of creating animal products might seem really bizarre now, but actually, if we look at the timeline of animal agriculture, there have been pretty big leaps in this as it is. So in the beginning, we actually never used to kill animals for their products. We were scavengers. We weren't really made for killing animals. And it wasn't about till 2 million BCE that we actually developed the tools in which to hunt. And we developed language so we could organise ourselves, and we began killing animals for their products. The next big revolution was domestication. And this occurred about 8,000 BCE. And this is when we started to keep animals and farm them in the way we kind of are more familiar with today. And then the next big leap is when we stopped having this sort of circular system and it was a lot more linear. And this was industrialisation. So this occurred predominantly, it took off when an abundance of nitrogen from World War II was then put into crops, which was then put into animals. So what's next? And why can't culturing be part of this future? From an animal ethics point of view, it kind of makes sense. And then from an environmental view, it actually makes sense. So from the most recent life cycle assessment, we projected that we would produce 75% less greenhouse gas emissions. There'd be over 90% less land use and over 95% less eutrophication potential. Plus, these products can be made in a sterile environment, which sounds really creepy, but actually it will considerably reduce the foodborne pathogens that are in our system. So this was kind of great. I learned all of this at university, and I came out of university really inspired. I suddenly knew what I wanted to do with my life, which for a scientist was pretty cool. You end up going into research, and I was like, cool, I can do that. But the problem with research is you need funding, and for funding you need money. And as a recent graduate, that was something I had nothing of. So I started to look at where I could get money for this project. And the problem is cellular agriculture lies between two very, very established fields, medical science and food technology. And it actually has really big splashes of art and design in, because we're creating something that has essentially never before been created. The problem is it doesn't receive funding from either, and it isn't really recognised by either as well. So I was now lost. I had no idea how to get money for this project. So I put together what I fondly dubbed the dream team, which was Mark Post, who was the only person actively working in cultured meat that I knew of. He turned out to be a Meg babe. He just agreed to help me in any way he could, and he ended up being my supervisor. New Harvest, again, said that they'd try and help me find this funding. And Professor Lucy Di-Silvio of King's College, who's actually a really open-minded tissue engineer who works on bone regeneration, usually for facial disfigurement. So it was great. I had a project, had an idea, I was inspired, I had a team, and I still had no money. And I very, very quickly exhausted all the conventional routes that you think of to find PhD funding. And so I actually got kind of desperate. This is no joke. I actually started hanging around where I thought rich and famous people might be, in like cafes and train stations and banks, and it didn't get me anywhere. And I actually almost gave up as well. I took a PhD in antibiotics, which is kind of ironic. And in celebration, my friends and I went to a festival. I got a real job after graduating, hooray. I went to this festival and I went to a talk by Paul Dolan. And he's a professor at UCL on happiness. And he said, without purpose or pleasure, you will never be truly happy. And one without the other, again, you can't be truly happy without that. And so I was that girl in the corner wearing a catsuit and a sparkly hat, like crying, being like, I know what I want to do in my life, and creating antibiotics is not it. And then I went back to my tent, sort of tail between legs, and checked my phone for the first time in a couple of days. And there was an email, and the email was from New Harvest. And they'd found funding through themselves and 2 philanthropists in the US for the project. And I couldn't believe it. I was on cloud 9. I got all the money to do this thing that I wanted to do for so long. And so I ran outside the tent and I was like, guys, I'm going to do the project. I'm going to be the meat lady. And there was absolutely no response. And I would have thought that would warrant something, but I'm not sure if it was because it was a festival and stranger things had happened, or because it was me and stranger things had happened. But they did have one question for me, which I'm sure that you guys would like to know. How do you grow meat in the lab? So the current system, my current system is based upon Maastricht system, because beef is my speciality. So we take a muscle biopsy from a cow, we separate out the stem cells which lie in the muscle. This is a really simplified version. We take these cells and we multiply them, so we take a few and make many of them. We then have to differentiate them, so we change them from muscle stem cells into mature muscle fibres. And to do this, we cast them in a gel, we put in anchor points, and at the moment we actually use Velcro, which act as tendons. So you put your cells in gel with Velcro, and essentially the gel contracts and the muscle fibres self-stimulate. I have a really cool video that I can put in here of basically they'll twitch. And you can add an electrical current, and we're working on other ways of stimulating them, and you form a muscle fibre essentially. And then if you harvest, say, 20,000 of these, you can make a burger out of them. However, there is inputs and outputs like any system, and there is a long way to go before this becomes a commercially viable product. But my actual project works on thicker tissue, because processed meats don't drive the meat industry. Whole cuts do. So I work on getting oxygen and nutrients to all of the tissue and removing all the waste. And that's what I do on a daily basis. So I often get asked, what does the future hold for cellular agriculture? Where are we going next? And I've been doing the PhD about 6 months now, and for a long time I really deflected this question, because if I was honest, I didn't really know. I knew it was an amazing technology, but I also knew that there's not one solution to all our problems, and we really, really need to look at the way we consume as well. So I looked at this quote by Winston Churchill, and it paints such a dystopian scene for cultured meat. And it got me thinking, maybe, yes, the way we produce many of our animal products is absurd, but maybe it's not animal products themselves or animals that are absurd. So I did a lot of research. I talked to a lot of people, I went to a lot of events, hang around some more banks, and I learned something. That aside from industrial farming, there are people that are farming sustainably, or they're trying to, but they're being pushed or pulled economically to farm against nature instead of with her. And if anything, I took away one really, really big point. That with biological systems, whether inside or outside the lab, you cannot break them down into single ingredients. Just as every cell has a specialised and unique function in forming a tissue, every plant, animal, bacteria and fungus has a unique and specialised role in creating our ecosystem. Yet, we continue to grow cells on plastic flasks in the lab, just as we continue to farm non-native animals indoors grown on monoculture grain. And actually that prompted two other curious scientists and I while I wasn't in the lab, to look at the ecological side of this, and we created Future Farm Lab, which looks at teaming old practices and new technology to create a more robust and resilient food system. Got one more, is that okay? So the last question was, how does cultured meat fit alongside agroecological farming? So this is something that's quite interesting, because what if a farmer could have a collection of cells and in order to grow meat or milk or eggs or some sort of product, so that if there was a bad harvest, or the climate caused a bad harvest, or if there was that you're waiting for TB results to come back and they didn't go as planned, it wouldn't mean the end to your business. What if cultured meat could be part of a more robust and resilient food system than our current one, and part of a real future? Thank you.